So we're looking here. How does the food industry set its prices? The food industry is made up of a collective of diverse businesses that together make the majority of the food consumed by the world's population. How do these businesses decide which items to advertise and how much to charge for each product? So, question one is just you personally. What types of food or drink do you see advertised often? And for what types do you see very little advertising? So let's start with, what do we see lots of ads for, food or drink?
McDonald's.
Okay. Let's exclude, let's don't think about like fast food. But you're right, like there would be fast food commercials. Let's think more like at a grocery store. All right, Coke. Okay, soft drinks. Pepsi. Sprite. Okay, cereals. Doritos used to make great commercials. They still make commercials? Maybe. Chips. Chocolate.
Raisin Bran.
They'll finish cereal, right? It's a cereal. So cereals, chips, chocolates, soft drinks. They also said smoothies. I don't know if I've ever seen a smoothie ad, but that's okay.
Alcohol.
Yeah. Alcohol. Sure. You're right. There are lots of ads for alcohol. What are there not ads for? Bread. Besides the Wonder Bread car driven by Ricky Bobby. That's a great. Corn. Yeah, I've not seen. Big nump. A big. What's it? What's the corn guy say? A big lump with knobs. It has the juice. Can't imagine a more beautiful thing. Milk. You know, there used to be a Got Milk ad when I was a kid, but not often. What you seen? What kind? Recently?
Yeah.
What kind is it? Okay. Okay, we'll take that one out. When's the last time you saw a good banana commercial?
Eggs.
Eggs? Yeah. What's up with that? People just complain about the price of eggs. You never see them advertised. So.
Toilet paper.
No, there's toilet paper.
Yeah,
You don't eat.
Yeah, we're thinking food and drink. Food and drink. Not just
The little bears. The
the
bears.
Charmin bear.
Yeah.
Licorice.
I did used to see Twizzler commercials. That is a licorice. Let's just stick with this. I like this list we got here. So we've got some things that we see advertisements for, some we don't. Why?
Because the stuff on the bottom is stuff everyone has to buy anyway.
Okay.
It's more healthy.
Okay. So we don't have to advertise needs. Healthier options. Okay. Everybody happy with that? Makes sense what we've done. Now let's get a little more mathy with it. The lines below model the possible relationship between the price and the number of customers for two popular supermarket purchases, baby formula and soft drinks. So when I look at this graph, the first thing I want to do is make sure I identify my units for each axis. So for instance, the x-axis here is representing the price. right? So this is a price of 0 versus a price of 120. It's in dollars, it says. So, and then here we've got the same thing with soft drinks for the price. The Y's represent how many customers there are in millions. So this would be 20 million customers, 40 million customers, and so on. So what do you notice about the graphs? And what do you wonder? So just, there's no right or wrong here. What are some things as you look at this that you notice? They do intersect. There's an intersection point. Okay. Hold on. There's an intersection point. The market. There's more of a market. Let's say it that way. More of a market for soft drinks. Okay. The cheaper it is, the cheaper they are, the more customers. Okay. Anything else? Okay. The customer base. So yeah, that one's going to go more in my next question. So I'm just going to wait. That's fine. But see how the next one's talking about customer base with price increases. So we'll get there in a second. But yes, you're correct. What about people are willing to pay more for formula than they are for soft drinks, right? Even as the price of formula went up to $70, $80, $90, there's still people that would pay that. So that's something else we could notice. All right. I don't have room to write that down, but B, which customer base, formula or soft drinks, is more swayed by an increase in price? So which customer base is more swayed? Y'all know what that means? Like it's going to cause people to stop buying. So which customer base is more swayed by an increase in price? The soft drinks. And how do we know that?
The rate of change is greater.
Okay. The tilt of line is steeper. I'm going to word it that way. You said the rate of change is greater. This is where we get into some technicalities. It's not greater because, just for example, if this was -8, this one's -2, right? Just roughly estimating. -2 is the bigger number. -2 is greater than -8. It's more negative, or it's more steeper. But I can't say it's greater because in math terms it's not. Even though I know what you mean. And I know, yes, it is. It's steeper. But the wording is going to matter a lot on the AP test. If you word it that way, they'll count it wrong. So, does that make sense to everybody? Why we can't say it's greater? Okay. Soft drinks, the tilt of the line is steeper is how we know. Very good. Anything else we need to add to that? Y'all good with that? I'm good with that. 3, look at the data in the table below. Calculate the company's revenue for each item when the price is $10 and when the price is $45. So revenue is just the amount of money they are bringing in, right? Not necessarily their profit, but just the amount people are paying for their product. So at a price of $10, there are 200 million customers for soft drinks. So the revenue here would be 200 million people are each paying $10. That would be 2,000 million dollars or 2 billion. All right, is the way you want to word it? If we have 2,000 millions, that's 2 billion. This one's a little bit better. I have 78 million people that will pay $10 for formula. So how much money in revenue would the formula company be making? They'd be making 78 million 10 times, which is 780 million. Or if you want to, 0.78 billion, which is not that pretty, right? I'd rather say 780 million. Okay, but now what happens if the price jumps to $45? Well, the amount of customers for soft drinks is down to 30 million customers. So 30 million customers at a price of $45 is 30, so that's 135 million. 1,003, no, I missed a zero. 1,350 million. That's what y'all got if y'all did 45 times 30. So 1,350, not 135. I was multiplying by 3, not 30. All right, what if there were 52 million customers buying formula at a price of $45? That would be 90, 180, 225, and 90, 225, and 90, which is 2, 3, 4. What you got? 2,340. 2,340. Sorry, just ignore my mental math. Just when I'm just talking, it's just gibberish. It means nothing. Sweet. So just looking at this table, what's it saying? So the soft drink company charging $10 or charging $45, which one's better for them? How do you know that?
More people buy it.
Right, more people buy it and they're making more money as well, right? So there's a sweet spot. Maybe they could charge a little bit more and not lose as many customers, right? We don't know where that is exactly, but we know all the way up to 45, they are making $650 million less, which is not great, okay? On the flip side, look at the formula company. When they charge $10, they only make $780 million. But when they charge $45, they made $2,340 million. So their price or their revenue went up as the price increased. So interesting. So do you think it's a good idea for companies to always charge more? No. Explain. So let's talk about it from the soft drinks point of view. Why is it not good for the soft drink company to charge more? I couldn't hear. I'm getting old, apparently. I could hear a voice, but I could not hear what was being said. So.
The company makes less money.
If you overcharge for a product, if you overcharge, that results in fewer customers, which ultimately resulted in a lower, in less revenue. Which is what you were saying. They make less money. Okay? That's cool from the soft drinks point of view. What about the formula point of view? Is it a good idea for the formula people to charge more money? Can anybody take a contrarian view? From a money-making point of view, I agree. They should charge more. But can anybody explain why maybe they shouldn't charge more?
You charge too much for it, people can't buy it. When their baby's starving.
It seems like a much bigger deal to price people out of formula than it is to price people out of soft drinks, right? Because it's could be life or death in that situation. So, also, some foods are necessities. And it's better to keep them reasonably priced so more families have access. Okay, so again, the first thing I want us to do is label the axes. So first, the x-axis represents the price of formula in dollars. And the y-axis represents revenue in millions. So again, revenue is just strictly the money they're bringing in. Revenue in millions. Okay? With the labeling. Everybody knows their X and their Y axis. I hope. Okay. So 5. I'm going to try to get you guys to answer these without me. Or like, I'm going to help you. But I'm not going to break it down and explain it first. Okay? I want to see if you can figure it out just looking at our label and answering these questions. Does each equal increase in price change the revenue by a constant amount? So when I look at equal increase in price, what is that? What's the increase in price? That's the change in X. So I'm looking at equal input intervals, which we talked about yesterday. So like if I look from 0 to 10, how much is this went up by? This went from 0 to 800. I went up by 800. So from 0 to 10 went up by 800. What should 10 to 20 do? Go up by 800. Does it go up by 800? It goes from 800 to 1400, which is a growth of 600. So is it a constant change in the outputs? No. So each equal increase in the inputs does not produce a constant change in the outputs. Why not? So we could put in words what I just said, right? From 0 to 10 on the X's made the Y's go up by 800, but from 10 to 20, it only went up by 600. That's one way you could explain it. Can anybody think of a better way to explain it? That's not so many words. It's not linear. Thank you. Right? For us to have constant rates of change, that's what I was just looking at, the rate of change, it would need to be a linear graph. And this is clearly not a linear graph. And then they explained, after that, they did what I said. So I'll write it down. I didn't know that they said what I said. Increasing price from 0 to 10 increases revenue by 800 million. I'm going to run out of space. Y'all can fill it. But 10 to 20, only 600 million. So we carry that if I abbreviate, make enough sense of that. You've heard me explain it. So. All right. 6A, the new intern at the company suggests selling the formula for $20. Is that the best price? No. How do you know?
It's not the point that they're making this revenue.
Right. It's not at the point they make the most revenue. That's fine. Not the point where they maximize revenue. All right, I'm happy with that answer. The answer they gave, they said you could charge more and make more. Right, which is kind of just a different approach. It's the same idea. A second intern says, sell it for $80. Is that the best price? No. Explain.
Revenue's going down by then.
Say it again, sorry.
Revenue's going down by then.
Okay, so you're looking at big picture graph, and the revenue is on its way down at that point. Okay. Revenue is decreasing at this point. And that's thinking about an instantaneous rate of change, right? The slope of a tangent line at 80 would be a negative slope. Everybody can draw a tangent line? We talked about yesterday to that graph. So because it's negative, the slope would be decreasing at that point. So again, the way they said it, you could charge less and make more. Right, which is what you're saying, just in different words, different approach. And then C, if the goal is to make the most money, what is the optimal price for the formula?
$58.
Oh my gosh. How do you know?
The graph ends at 118 divided by 2.
Oh, okay. Mr. Fancy Pants. Okay. You said it ended at 1. It ended at what? 118?
418, that's right.
So you divided by 2 and got 59?
Oh, wait, yeah, no, wait, 59, yeah.
59, okay. Exactly $59.23. I don't know. The answer they were looking for was about 60, right? Which is good. That's still good. I like it. If you knew for sure that it was quadratic, which is degree 2, that what you did is perfect, we'd have to know that was exactly 118, which is close, right? So we're somewhere in that ballpark. I exaggerated by going right to the penny, but that would be fine. If you said what you said, you'd be good. And how do we know this? Revenue is at its peak. Was okay with that? All right, let's keep answering these, and then we'll go back and I'll teach the stuff I need to teach. 7, at what price will the company make no money on formula?
At $0 and $118.
So at $0 and at, they said 117, so 118 would be fine. Again, anywhere in that ballpark, their take. If you said a number between 110 and 120, they would accept it.
Okay.
If you said 111, they would accept that, even though it's not close to 111. So we'll go with yours. 118. Why? Why is the company making no money when they charge $0 and $118?
No one's paying for it at 118.
Okay.
Not selling it at 0.
So at $118, no customers will buy. That's why at $118 you're making no money. At $0, you're just giving it away. It's hard to make money when you don't charge for it, right? So there could be a bunch of customers at $0, but when or why might companies use factors besides revenue to determine their price? So this is what we kind of talked about earlier. So I'm just going to put their answer and not spend a lot of time here because we've kind of already discussed it. Here's what they said. For items like baby formula, maximizing revenue might not be the best because if families can't afford it, there are serious consequences, right? And we kind of have had that discussion already. Everybody good enough here? I can go to... I'm going to get a clean slate here for me to explain stuff because I know mine gets messy sometimes. You guys might can do a better job than me. So let's look back at the graph that we had. This was the price, and this was the revenue in millions. Some things we need to talk about here. When we look at graphs, we read them like a timeline. What that means is I'm reading from left to right. So what is happening initially as I look at my graph from left to right? Whoops, wrong color. I want to do this. All the way to here, the R value or the revenue is increasing. Can y'all read that? That green's terrible. I can barely see it on mine. Let me get a different. Then what happens after that? Going left to right?
Decreases.
R is decreasing. In this case, R is just my Y values, right? R increasing, R decreasing. That's the revenue. This whole time, as I'm going from left to right, the price is increasing the whole time because I'm going from left to right like a timeline. 2 more points here we need to label. Right here at the top of the parabola, this represents the maximum revenue. And then a couple of other points that we talked about were these x-intercepts, which were down here. So the way they explain that, they say this is where the R of P, so the revenue at this price is 0 for my x-intercepts. And we explained why that was. Everybody's good with this? All right. So because it was increasing initially, here's how we would say that. This graph is increasing from 0 to 60, 59, whatever we want to say. Okay? It's increasing from 0 to 60. Have you guys done interval notation like this before? In parentheses, that almost looks like an ordered pair, but it's not an ordered pair, right? This is saying it starts increasing when x is 0. It stops increasing when x is 60. Okay? 0 to 60. That's where it's increasing. Where are we decreasing? 60 to 118. Decreasing from 60 to 118. Some things we need to make sure I point out. Increasing and decreasing is always a parenthesis. It's never included. So what I mean by that is you never have a bracket for increasing or decreasing. Right? You know the parentheses versus the bracket. Never a bracket for increasing or decreasing. And then a new idea here is this being the max revenue. The word we're going to use, a new word we're going to use, is going to be a relative maximum. Or I will sometimes say local maximum. Just depends on the textbook. AP uses relative, and when I learned it, I used the word local. That's the way they taught it. But they mean the same thing. What this means is, in this case, our relative max is the same as our absolute max, right? This graph reaches a hilltop here, but this is the highest it's ever going to be. That makes it be an absolute max. The reason we have to introduce this relative max and relative is if I have a graph that looks like this. Okay? This graph has a relative max here and a relative max here. And it has two relative mins, which is minimum or local, because it's the lowest point of any in its area. Kind of like how we talked about going from a mile distance to getting very, very close. So this is essentially relative max. This is as high as it gets anywhere near it. And this is as low as it gets anywhere near it. But when you talk about this graph, does it have an absolute maximum? Is there a point that it's never going to get higher than? No, because this arrow means it's going to continue up forever. What about an absolute minimum? Do I ever reach a lowest? So we can have relative maximums and relative minimums, but not have absolute maximums and absolute minimums. Okay? One other thing I want to point out, think about tangent lines. What is happening with tangent lines at every local extrema or relative extrema, which is just the max and mins together? What's happening with tangent lines at every one of these points? Try to draw a tangent line in your head. Where would they be?
Just go straight.
So what can we say about all of those tangent lines? The slope is 0 for those tangent lines. You can also think about, this is the point where the tangent lines switch from being positive sloped, but fixing to be negative sloped right after that, right? So those points where the tangent line slope switches from positive to negative or from negative to positive, those are all of our local extremas, our local max, local mins, relative max, relative min. Okay. Sweet.